So in this problem, we're given the area of a regular hexagon, and we want to know what the apothem length is. 3, 4, 5, 6. So there's your hexagon, and this is your apothem. And that's what we want to find the length for. So we start with the formula, 169 point blah 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 equals 1/2 of the apothem times the number of sides times the side length. And we're going to solve this equation for A. So we'll start by dividing both sides by 3. So we have apothem times side length. Give me a second in the calculator. Divided by 3. 56.58 and a bunch of decimals. So here's where the crux of the problem comes in. We want to find a way to replace s because we can't find two variables at one time. So that's where our nice right triangle comes into here. So this is your apothem, this is half of your side length, and this angle for a hexagon is 30 degrees. That's 360 divided by 12. That's how we find that angle. 2 times the number of side lengths. So there's a tangent relationship between the side length and the apothem. And it turns out that the side length equals the apothem times the tangent of 30 times 2. So instead of having an s, we're going to now have apothem times tan 30 times 2. So I substitute s there, and everything else stays the same. And that is always the relationship. Anytime you want to replace s, you always do a times the tangent of the angle times 2. Replace in there. So we can simplify a little bit and get a squared times 2 tangents of 30 equals 56. And now we divide both sides by 2 tans of 30. And when you put this in your calculator, make sure you use parentheses over here, or your calculator might get confused. So divided by parentheses 2 tans of 30, making sure you're in degree mode also. And that's 49. So the square root of 49 gives me an apothem length of 7 units. So the key here is replacing s with its trigonometric equivalent. The side length equals the apothem times the tangent of the angle times 2.